Hey guys, how we doing? We are starting what is essentially chapter 2, which is about representing motion. I know right now this is going to be tough for you guys to see, but just know this has been posted in Canvas for you to access. All right, I'm just using this as a guide as I talk to you about some things. All right, so first off, representing motion. The first thing they want you to understand is that how do we know motion even existed, right? How do we know it even happened? Well, it happened because we had to see a change in something, right? I know the car's moving because the car started here and ended up here. Just like you know when somebody's walking, and that's called a change in position. Okay, so that is how we recognize motion, is when we notice something has changed. All right, now there's a couple of different types. Right, you have what's called straight line motion, okay, which is the one that we're going to probably focus on the most because it's the easiest to understand. There's also circular motion as well. You guys have dealt with circular motion a lot of different ways. If you've ever been to the fair and gotten on one of those rides that spin, not only are we moving, left, right, but we could be going top, bottom, or rotational motion as well, right? So there's not just straight line motion. Sometimes it's circular, okay? So, what is motion? How do we know? Well, basically motion is a description of where we are at what time. Okay, so place and time are going to be two very key factors in understanding motion. Now, we're going to look at some motion diagrams. There's three main types. You have what's called consecutive image diagrams. We'll take a look at what those look like here in a second. We have combining image diagrams, and we also have particle models. Actually, one of the first labs you're going to do virtually, which is going to be kind of interesting, is one where it deals with the particle model. Okay, so some definitions, they're in there. Motion diagrams, where it's a series of images that show you how the motion is changing. Particle model is represented by dots, but we're going to show you some examples right now. So like here's an example of consecutive images. Okay, you can see she has her dress, and then as you progress through the images, you can kind of get an idea of what her motion actually is, right? So that's a consecutive image diagram. We also have combining, where just in one photo, they show you the entire transition of whatever the motion was. So I can look at this one photo, and what it appears to me as if this bird was flying and it's getting ready to land, right? So I can come up with an interpretation of what motion this is just based on what I'm seeing in the diagram, okay? Lastly, we have particle model, and I know this is really tough for you to see on this video, but what it's showing is this person running, and instead of actually drawing a person, what they're doing is they're showing these dots, okay? And as you can see, the way the dots are spaced is going to give us an idea on how fast or slow or how consistent this object is moving. Right? So, if you have questions, you can comment below the video if you want. You can email me, but that's the first part of this second module. Okay, so even though this was introduced as chapter 2, it's module 2. Right. So the coordinate system gives the location of the 0 point of the variable you are studying and the direction in which the values of the variable increase. Look, I know you can read the definition, and that may not mean anything to you. Okay, basically what it's saying is, where was it at the beginning? Give us a location for that. And then where was it at the end? That's coordinate system. So I know, like, if you were, right now at, 11:20 a.m., you are at your home or at your desk or at work, right? Well, where are you at 3:30 p.m.? Okay, so coordinate systems kind of help us gauge how people have moved based on where their location was at a specific time, okay? Origin is going to be important. Where did this all begin? Right, that's what the origin is. Where did this motion begin? Right, because we have to have a starting point for all types of motion. Okay? Now, a couple of very important terms here. We have position and we have distance. Okay? The actual definition, position, the distance and direction between an object and a reference point. Right? I don't know, you probably have done this before, especially for those of you who are not good with directions. But, maybe you don't know the street names, right? So you don't know that right outside of the high school is Warren Street and, 7th Street or Wildcat Way, right? Maybe you don't remember those names, but you remember where Starbucks is. So sometimes if mom's, telling you, hey, where are you? I want you to come home. You may not say, well, I'm on Warren Street, because you may not even know what street you're on, and mom may not even know where Warren Street is. So a lot of times you'll say, we're right by Starbucks. That gives them a frame of reference as to where you are. Okay, so a position is based on where you are relative to a reference point. I am 5 feet to the right of my bed, or I am 20 miles outside of Bakersfield, or 20 miles outside of Taft, right? That is a position based on a point of origin or a reference point. Okay? Distance, though, is the actual path that was traveled. So when someone asks you what's your position, they want to know where you are based on a reference point. If someone said, how far did you go? Well, you went 5 miles, 1 mile, 10 feet, whatever that is. So distance is the entire path that was traveled. Okay? Origins establish a 0 point. An object can have a negative position. So here's what that means. Okay? Positions can have positive or negative numbers. All right, so if I establish this point that I'm standing as the 0 point, and then I tell myself that everything this way is considered positive. So right now I would be at +1, +2, right? And back here I'd be back to 0. Well, if I have established this as 0 and this as +1, then if I'm here at 0 and I go this way, this would be what? It'd be -1, right? Just like this would be -2. So understand, physics, the math of physics is a little bit different than regular math in that negative numbers aren't always an indicator of we're subtracting something. Negative numbers sometimes indicate the direction in which something is traveling. And the best part about physics is you get to establish that direction. You get to establish whether moving right is positive or moving right is negative, or moving up is positive or moving down is negative. You guys get to establish that. So again, there's an example here. If a stop sign represents an origin and one person stands to the right of it and another stands to the left, one person has to have a negative position and the other has to have a positive one. Okay, this is kind of like the example I just gave. There's a couple of quantities you got to get familiar with, or not quantities, terms, sorry. One is vector. We're going to be dealing with a lot of vector quantities. A vector quantity is anything that has magnitude and direction, where a scalar quantity is just the quantity itself. So here's a good difference. If someone said how fast you're going, and you just said, I'm going 20, you just gave them a scalar quantity. You gave them the number. Scalars are just numbers, okay? Where vectors are not only the number, but also the direction in which we're going. So if someone asked you how fast you're going, if you wanted to make it a vector quantity, you would say, I'm going 20 towards Bakersfield. Now you've turned what was a scalar quantity into a vector quantity. Okay? So that's the main difference between the two. There's a couple of formulas that we're going to have to get familiar with, and I'll do some examples of those here in a second. Time interval, which is represented by delta t, which basically is, what was the time interval that passed, right? Was it a total of 10 seconds? Did we start something at 11:05 and end at 11:16? If so, how much time passed, right? So delta t is representative of what's called a time interval. Right? There's also a way we can figure out displacement, which is how your position changed. And some people mistake displacement for distance, right? So displacement by definition is the change in your position. Okay? So I'm going to try and use this as an example here. Let's say this screen was on the board, okay? And then you closed your eyes, and I ended up going through a couple more screens. And then you open your eyes and you see that I'm on this screen now. Did the position change? Yes, it changed because you're no longer seeing the same thing that you saw, right? But if you closed your eyes and we started on this screen here, if we started here, you closed your eyes, I flipped through the screens but came back here and you opened your eyes, what changed? Nothing, right? So that means there was no displacement. So, to give you hopefully a better example, I'm right here right now. Did I have displacement? Well, yes, because I was right here and I ended not where I started. So there was displacement here. Okay? Here's an example of zero displacement. I start here, I walk around, and I end up right back here. Did my position change? It didn't. I started here and I ended here. Displacement is how your position changed. Distance, though, would be different, right? Because I actually traveled a distance to do this motion to end up right here. So I traveled a distance, but my displacement was zero.